Hello, John here again, and this is video, or part 4, video 5, because I split the first one, of this Neptune Lander tutorial that we're going through. And what we've done in the past is we've done the basic physics engine, we've done the basic controls, in the last video we created our first landscape, and in this video we're going to learn about how we can detect, whether we've collided with the data on the screen from the sprite. So that's what this video is going to be about, is to learn how to do that. And it's a little bit finicky to do, but we will persevere and see what we come across. So let's get started, shall we? So here we are. So this is where we were before. And so what I'm going to do is we're going to create a brand new basic file, and we're just going to call it data sprite collider, and we're going to try and just write a small basic program to see if we can detect that we are hitting any data on the screen. So what we need to do, we need to create a sprite. So what we're going to do is we're going to nick the basic sprite routines from here. So let's grab all that. Or in fact, we'll grab that and make it black as well. Yeah, well, we'll grab all this, I think. Yeah, we'll grab all that. Put that in there. We'll take out what we don't need, which is this line here, because that's to do with the character set. And that's to make the screen work. Right, so what we've done here is we are activated sprite 1, we're pointing it to 190, we're setting it to be 60 by 60, and we're making it black. But instead of reading some data, right, we're just going to poke it with 255. So we should end up with a black block. So let's run it and find out. Yeah. So F5. Excellent. There we go. So we got our black block. So let's what we're going to do now is do 70 print clear. So that should clear the screen. And what we're going to try and do is we're going to put some lines in. So let's run it again and work out where we need to be, because we need to put some data on the screen so we can do the collision detection. Right, so yeah, we'll do it there. So we'll say it's down to right 2, and then down 2, and it's right 2, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, another right 16. So we'll set that up. So we said it was down 2, and then right 2. So we're going to put capital, let's put something, asterisk, there we go. And then we said write 16 again. I'll put another asterisk. Okay, save that, print that, run that. So we should end up with 2 asterisks. So see what happens. Right, so we've got 2 asterisks, and what we're going to do is we're going to send the sprite that way until it hits, and we're going to try and collision detect that, and then when we've detected the collision, we're going to send it back and then collision detect with that as well. So we need to set up a loop and start working it out. So we'll do the collision detection at 100. So we're going to, this is the point, so we've got x and y, so that's alright because we're going to modify x, so we need a new one. So delta x equals 0. No, make it 1, so we're starting at 1. In fact, we can do that here, so we're not affecting our looper. And so what we're going to do, we are going to poke, and we're going to poke the X register of the sprite, comma, peek the X register plus the X. So that should start making it go across the screen. Alright, so after we've moved it, we then need to check the detection. Okay, so there's some specific registers for that. So where are we? Multicolored, no, number of rows, so it's not that one. We've got scan lines. So what we do, and that's turning sprites on. Interrupt flag, here we go. So 53273, and we want to turn on the sprite to data collisions. So we need to, let's do a peek of that, 53273. Right. So what we need to do is, let's run it. I want to peek 53273. So we'll just let it run. Right. So print peek 53273, and we want to AND it. Oops, AND it with 15 because we only want the lower nibble, so the lower 4 bits. And so we've got 11. So 11 means 2. So 8. That's 8. So that leaves 3. So these 2 are on. So it looks like the sprite to data collision is already on. So let's have 53273 interrupt flag and write register to clear flags. So 1 for interrupts and 0 for no interrupts. So that's saying that. So 53274 is whether it's switched on. So we're enabling it, and then 532. So print. Oops. Print peek 53274. do the same thing again, and it with 15, and we get 0. Right, okay. So back to here. So it's saying that the light pen interrupt is on, and the sprite to data collision is on for interrupts, and the raster line is on for interrupts, but the interrupt enable is not on. So we need to set that to a 1 so we can start collision detecting. Okay, so we will, so it's 5.3, so we'll set it up here. So poke 53272, comma peak, open bracket 53272, because we don't want to mess around with any other register, or it with 2. So that's setting the, oh, did I close it? Oh, Wally, what a Wally. So we're setting a 2 in 53272. Well, that's the wrong one for a kickoff. So let's get back here. 53273. So we're making sure in 53273 there's a 1 in that bit there. So that's bit number 1, bit 2, bit 4, bit 8. And we need to do the same for 53274, is we need to put a 2 in that byte there. So let's do that. And then, and we do it again. Poke 53274, comma peak, one bracket 53274, or it with 2. So that's setting it up. That's setting it up. So there is another register that tells us when things have happened. So that's the enabling. Right, sprite to sprite collision. No, sprite to data collision. Here we go. 53279. And so this will have a 1 will appear in each of these bits for the sprite that's doing it. So we're using sprite 1. So bit 1 should have a 1 or a 0 in it. So we are going to be testing 53279 to see if it's set. Yeah. So here in our looper, so we're going to do if peak, open bracket 53279. Let's just make sure that I am right with that one. 53279. Yep. And with 2, because we only want to test for and with 1, because we're using sprite 1 equals 1, then but what we're saying here is if it doesn't equal 1, then we want to go to a line number that hasn't been created yet. So here is if it is detected a collision, then what we need to do is we need to make that dx value go in reverse. Yeah, we need the dx value to go into reverse. So what we're saying is, so what we're going to do is if dx equals 1, then dx equals -1. So If it's going this way across the screen and we hit something, then we want it to go backwards, so that's -1. And conversely, if dx equals -1, then dx equals 1. Now I know you guys are going to go shouting at the screen right now, and this is where we're going to say, right, go to 140. So if that hits it, it doesn't evaluate that one. So 140, so what's 140 going to do? So this is this where we're going to loop back round again? Yeah, I suppose it is. So yeah, so here we go to 100. So there is 140. Well, to be honest, that can go back to 100. Because we're doing the move there. Right, so we move it. Has the bit been set for collision? No. Move it again. Yes. If we're going in the positive way, then we start going in a negative way, jump past. If we're going in a negative way, then we go to the positive way. Okay, let's see what happens there. Let's see if we can actually detect. Well, this will be interesting. Okay. So there's the block. And so that's saying it's detecting all right because it's going. Hang on. Are we using Sprite 1? Yeah, we are using Sprite 1, aren't we? So what's that saying? It's going that 3279 is always set. So what we're going to do is we're going to put a line in there, and we're going to say collision detect equals peak, open bracket, 53279, and then we're going to go print home down 6, comma CD, comma space. So we print out what CD is, and then we do our test of CD here. If CD, and so we can actually see what that peak is doing. Okay, let's try again. So it's saying it's not, but for some reason it's going backwards and forwards, backwards and forwards. So if CD and 1 is not equal to 1, then go to 100. But that is going backwards and forwards, so it's failing on this test. Okay, well we won't do that, we'll just say if CD is not equal to 1. Aha. So something's happened here because we're doing a collision detect. So where's it? Has it crashed on me? Yeah, it has. Wow. Crashed a basic program. No, I can't have crashed a basic program, surely. Yeah, it's crashed. Monitor. FFD4. Wow. Crashed it. Crashed the emulator in a basic program. So that was going backwards. So are we setting this up right? Let's rem that out. Let's do a bit of debugging here. So it's doing a collision detect, but it's back as soon as it's doing a collision detect. It's so it's still saying that it's doing a collision detect all the time. Okay, let's copy that, put in there. So I'm just wondering if we have to reset the flag every time we do a collision detect. Oh, cobblers. Absolute cobblers. Right. Right, okay. I think every time we read it we have to reset it. So let's have a look. See if it does it. Right, so it's going back, but it's stopped, and I think it's crashed again. Yeah. So we'll run that out. Whoa. We're getting somewhere. Because it hasn't crashed now. But it's saying it's on all the time. Five 53279. That's the one we need to read, isn't it? Do that. See if it's mucking about with the byte and the Vic chip. Well, it's moving back, but it's still saying it's set. It's still saying it's detecting. Okay, let's put the X on there so we can see where we are. Ooh, undo. Set. I'm just wondering if we've got a problem with our tests. I did say X, didn't I? Yeah. So why is it still saying 60? Ah. Dough. X equals X plus dx. Poke that with X. Come on, John. Get a grip. Right, so 46. Okay, so what we're going to do is we're going to say if X equals 46, then dx equals 1. So it's, when it gets to that side, then it should bounce the other way. Okay. So as soon as it gets to 46, it should start going the other way. There we go. Did you see that? You see that went 1. So we need to, we'll run that again and take note of the number. I think it was 150. Poke. 53248. 53248, comma 150. No. 151. Still, it's 3. That could be it. 53. Let's try 2. Does 2? No, it's just before it, so it's 153. So we need to check here. So if X is equal to 153, then dx equals minus 1. Okay. Let's have a look. Here we go. So it goes along, bounces, comes back. Bounce. Hey, look at this. Oh, what in the... Why did it miss that? Okay. We won't do, we'll do greater than or equal to, and less than or equal to. Maybe the basic is not running quick enough. Let's see what happens. Here we go. So it goes across, comes back, goes across, and you can see it's saying it's detecting it. Look. Right. So let me just take. I want to understand why we was having issues. Maybe it was just our maths. Right, I've taken that reset up. So when we read, before we read it, we reset it. So let's see what happens now. See if we're still okay. So it goes across, hits it, comes back, hits it. So we're all right there. So we don't need to have this re-establisher because it's already done. And so let's find out what that one is. See why? I'm just got a sneaky suspicion that. So it hits it, it stops. Yeah. Right. Let's So the problem we have is the 7.4 one. 274. So this is the interrupt enable. Oh right. We're enabling the oh right, so it's firing an interrupt, but we're not catching it. Okay, that's why that's failing. It's because we're firing an interrupt and we don't need to, because we're not using interrupt technology. But you would put that if you want to capture it as an interrupt thing. So we'll just run it again. Right. So that is exactly what we want to do now. Yeah. So what we'll do, because this is now 30 minutes, what we'll do is in the next video we will apply this detection to our game and just get it to, you know, every soon as it detects it's hit something, just get it to say end or something, because that seems to work now. Excellent. Right, okay, I will say ta-ta for now on this video. If you like what I'm doing, please hit that like button. If you don't like what I'm doing, fine, hit the dislike. Always leave a comment if you have one, and I will always answer them. And if you would like to support me in this channel, please become a patron. Right, I'll see you in the next video. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.